My name is Sejal Sawant, second year B.Pharm student, studying in Shivajirao as Sonari College of Pharmacy, Asangaon. Today I am going to explain the synthesis, reaction and medicinal uses of pyrrole, imidazole and oxazole under the guidance of the Poonam ma'am. Pyrrole, it is a 5-member heterocyclic compound containing nitrogen as a heteroatom. Its chemical formula is C4H5N and its molecular weight is 67. Here is given the structure of the pyrrole. So here we discuss the various method of preparation of a pyrrole. First is from furon. By passing the mixture of a furon, ammonia and steam over the heat rate alumina at 400 degrees Celsius, then we get the product that is pyrrole. The second method is from succinimide. Succinimide on distillation with the zinc dust is give the pyrrole. And third method is from acetylene. Acetylene and ammonia are passed through the red hot tube to yield the pyrrole. Fourth is Paal-Knorr synthesis. So in this reaction, 1,4-diketone compound reacts with the ammonia and it gives the derivative of a pyrrole. So here give the mechanism of the Paal-Knorr synthesis, and in this reaction we give the product that is derivative that is 2,5-dimethyl pyrrole. So fifth method is a Knorr-pyrrole synthesis. It involves the condensation of an alpha-amino ketone derivatives with a beta-keto ester in the presence of the acetic acid. Here is also given the mechanism of a Knorr-pyrrole synthesis. So let me discuss the chemical reactions. First is the electrophilic substitution reaction. So pyrrole has a lone pair on a nitrogen that we know, so which have a ability to donate the electron. So pyrrole is a more reactive than benzene and it easily give this reaction. So first one is the nitration. In this reaction, pyrrole reacts with the acetyl nitrate in the presence of the sulphonic acid to give the product that is 2-nitropyrrole. Second one is the sulphonation. So in this reaction, pyrrole is treated with a sulphonic acid in the presence of the pyridine. So it's give the product that is pyrrole 2 sulphonic acid. Then Friedel-Claff alkylation. So in this reaction, pyrrole reacts with the acetic anhydride to give the 2-acetyl pyrrole. Chlorination. Pyrrole reacts with the disulfuric dichloride, so it's give the product that is tetrachloropyrrole. Then Riemann-Tiemann reaction. In that pyrrole reacts with the trichloromethane, that is chloroform. Then it's give the product that is 2-formyl pyrrole. Then second one is the reduction reaction. So in this reaction, pyrrole reacts with the zinc and acetic acid to give the 3-pyrroline. But on reacts with the hydrogen in the presence of the nickel, it's give pyrrolidine. So third one is the oxidation reaction. In this reaction, pyrrole is oxidized with the chromium trioxide in the presence of the acetic acid to give the maleimide. Medicinal uses of a pyrrole. Pyrrole and its derivatives are widely used and an intermediate in the synthesis of the pharmaceuticals, medicines, agrochemicals, dyes, photographic chemicals, perfumes, and other organic compounds. So here is some derivatives and their medicinal uses. First one is pyrocyclidine. So it is an the anti-muscarinic drugs. Second one is atorvastatin. So it is useful to prevent the cardiovascular disease. Third one is the tripyrrolidine. So it is used as antihistamines. Fourth one is the elopiprazole. It is used as antipsychotic drug. Imidazole. It is a white or colorless solid that is soluble in water, producing a mildly alkaline solution. In chemistry, it is an aromatic heterocycle classified as a diazole, and it is a non-adjacent nitrogen atom. Its chemical formula is C3N2H4 and its molar mass is 68.077 gram per mole. Here we discuss the synthesis method of the imidazole. First one is the Radzhizewski imidazole synthesis. Synthesis of imidazole from dicarbonyl and alpha and ammonia. The reaction is complete in basically 2 stages. The first stage is dicarbonyl and ammonia condensed to give it diamine, And second stage is the diamine condensed with the aldehyde. So second method is from dehydrogenation of the imidazole. So condensation of the 1,2-diamine with the nitriles. So it is gives the imidazoline. So this imidazoline reacts with the barium magnet. So it gives the product that is 2-substituted imidazole. The chemical reactions of the imidazole. First is the electrophilic addition of an protonation. Imidazole accepts proton and it is act as a base. B is an alkylation. Firstly, imidazole reacts with the alkyl halides and it gives the an-alkyl imidazole salt. So this salt can lose an proton in an equilibrium with the unreacted imidazole and it gives the an-alkyl imidazole. Then this an-alkyl imidazole is again reacts with the alkyl halides. It gives the N1N3 dimethyl imidazolium salt. Second one is the electrophilic substitution to carbon. Nitration, then sulphonation, halogenation, and third one is the imidazole catalyzed ester HL. So imidazolyl group of the histidine reduce present in hydrolytic enzymes is functional as a ester HL. So first one is the imidazole as a base catalyst. So activates water for the attack to carbonyl C. B is the imidazole as a nucleophilic catalysis. So imidazole directly attack to the carbonyl C. Medicinal uses of the imidazole. First one is the azole antifungal agent. Example is the ketoconazole. Then second one is the antihistaminic drug that is cimetidine. It is used to treat and prevent peptic ulcer, then gastroesophageal reflux disease that is GERD and heartburn. Third one is the antiprotozoal agent that is used in the amoebic dysentery. Fourth one is the azathioprine. So it is the immunosuppressive anti-metabolite prodrugs and anti-cancer agent that is immunosuppressive agent. Oxazole is a present compound for a vast class of a heterocyclic aromatic organic compound. There are azoles with an oxygen and a nitrogen separated by one carbon. So here is given the structure of the oxazole. Its chemical formula is C3H3 and O and its molar mass is 69.06 gram per mole. So some synthesis of the oxazole. The first is the Robinson-Gabriel synthesis. Second one is the from an alpha hydroxycarbonyl compound and third one is the from the isocyanate. So chemical reaction. First is the electrophilic addition of the nitrogen. So as we know the oxazole is less reactive compared to the imidazole because of the presence of the more electronegative oxygen. Protonation. So in that oxazole accept proton and it is act as a base from the oxalium salt. Second one is the electrophilic substitution to carbon. So it is a less reactive because of the oxygen present in the heteroskeleton. Its reaction is possible at the fifth position and if ring is activated by a EDG. And nitration and sulphonation are the more difficult. Third one is the Dahl's-Alder reaction. It is act as a dienes. So in Dahl's-Alder reaction, oxygen atom is highly electronegative. So conjugated double bonds are readily available. Oxazole readily undergo Dahl's-Alder's type cycloaddition across the 2,5 position. Then as I give the mechanism. Second is the Nordrat-Eva pyridine synthesis. Synthesizing pyridine derivatives by Dahl's-Alder cycloaddition between an azidine and dienophile followed by an extraction of the resulting bridge of the bicyclic intermediate. So then medicinal uses of the oxazole. First is the antifungal agent. Benzene are the natural products with the 2-oxazole group. Here is a given structure of the benzene. And second is the oxaproxine. So is non-steroidal anti-inflammatory agent. So it is used to symptomatically treat inflammation and pain.